Welcome to part 5 of our series on quadratics. Okay, in this video I'm going to introduce you to the quadratic formula. Okay, here it is on the top right here. Okay, now this comes from a process called completing the square, and I will explain in another video exactly how this is derived and where it comes from. But for now, we'll just accept it and use it as it is. And it relates to the general quadratic equation, ax squared plus bx plus c equals 0. Okay, so it's going to return two values of x, and they're going to be the two places where the graph crosses the x-axis. So in this example, it's going to be those two places there. So this is the graph of y equals 3x squared minus 4x minus 1. Okay, and you can see it's got two solutions there and there, which is where the graph crosses the x-axis. And that's what we're going to find using the formula. Now you may be thinking about factorizing it. Okay, so if you did try to factorize this, you would be doing 3x in one bracket and x in the next, and you'd be looking for the factors of minus 1, which are plus 1 and minus 1, and you would be seeing if when you multiplied that out it gave you the minus 4x in the middle, which it doesn't. So you'd swap the minus 1 and the 1 over, try it again, and you still would find that it wouldn't give you the minus 4x, because this quadratic here won't factorize. Okay, now in another video we'll look at what that means about the solutions, but for now it doesn't factorize. The only way we're going to solve it is using the quadratic formula, and that's what we're going to do next. So the first thing is to relate this to the general form here and to identify explicitly the values of a, b and c. Now a is the number in front of x squared, which is 3. b is the number in front of x, or what we call the x coefficient, which is negative 4, and the c at the end is the constant, the number on its own, which is negative 1. Okay, so now that we've identified those three values, we apply them to the formula to find the values of x. So we start by saying x equals the negative of b, so it's the negative of minus 4, okay, plus or minus the square root of, okay, b squared, so it's negative 4 squared, minus 4 lots of a, which is 3, times c, which is minus 1. Okay, and all of that has to be divided by 2a, which is 2 times 3. Okay, now I've written it in full. I've used brackets carefully around every negative number. You could put that on the calculator as it is, first using the plus sign, which will give you one of the solutions. Do it again using the minus sign to get the other solution. But it may be on a non-calculator paper, and you're required to give the roots in surd form. So let's continue on that basis. So the first part is the negative of negative 4, which is 4. Okay, plus or minus the square root of what's under that sign, square root sign there. Now this is going to be, okay, minus 4 times minus 4 is 16. Take away 4 times 3 times minus 1 is negative 12. So you've got 16, take away negative 12, which is 16 plus 12, which is 28. Okay, and that's all divided by 6. Okay, now you should now notice that this is the same as 4 plus or minus. Now root 28 is root 4 times root 7, which is 2 root 7. Okay, and underneath that we've got the 6. The next thing you should notice, if you were simplifying this expression, is that there's a common factor of 2 on the numerator and denominator. So this actually equals 2 plus or minus 1 root 7, or just root 7, over 3. So all I've done is halved the numerator and halved the denominator to simplify it. Okay, it's like cancelling down a fraction. Now, that means there are 2 values of x, which there would be because you can see it's crossing in 2 places. The first comes from 2 plus root 7 over 3. Okay, and the second solution comes from x equals 2 minus root 7 over 3. Now, if this was a non-calculator paper question, then it would say leave your answers as simplified surds, and that's what you've done here, and they would be the answers, okay, exactly as they are there. And you should be able to identify which is which. So the one on the left here is the smaller of the 2 solutions, which would be this one here, and the 2 plus root 7 over 3 would be the value of this. Now, if it was a calculator paper, it could well say leave your answers to 3 significant figures. Okay, so if you put that on the calculator, the first one comes to 1 point, I'll just do this as well, it comes to 1.5485, and it goes on after that, 5485 ... Okay, and the other one is x equals 0 minus 0.215, sorry, 2 and then it goes on. Okay, so you could round those to 3 significant figures or whatever it asked for. All right, now just to give you an idea on this to see where those points are, if you look at the graph, that one certainly does look around minus 0.2, doesn't it? And this one here is a little bit over 1.5, and that's in fact what it is. So the key thing that you might have picked up from this is that if you have to use the quadratic formula because it won't factorize, then if it has solutions, the solutions are irrational numbers. In other words, they can't be written as exact fractions. They have to be written as surds. They can't be written as one integer over another or as a whole number. Okay, and that's the case here. So these are not numbers that can be written exactly as a fraction. They are irrational numbers, but they are solutions to the equation. Okay, so what I've done here is just introduced you to the quadratic formula and shown one example of how it's used. Okay, in another video I will go into more detail about how the quadratic formula is derived and other effects of using it on different types of quadratic. Okay, we'll end that now.